Hello everyone, this is KK Mathematics, the solution to your mathematics. Today we'll be dealing with parabola. Before we talk about parabola, it's important for us to note of things we are familiar with. Now, if we consider the x-axis and the y-axis, we know that a quadratic formula with a quadratic curve, it goes this way, especially when RA here is negative. Now, in the same way also, if we consider the x and y axis, in sketching a graph as this, where y equals x squared, we'll have the curve in this formula passing through the origin here. So, having y be equal to x squared, we can rewrite it to be x squared be equal to y. In also the same way also, if we have a graph of x be equal to y squared, we are familiar with what we just said earlier on. However, when it comes to a situation where we have an equation as this, and we are to sketch this graph, this is not familiar. This is not something we are familiar with. And so we know that. So with this, when we look at this curve, this equation, its curve is going to face the x-axis, which is unusual to the normal quadratic function curve. So you notice that the curve is actually facing the x-axis, which is different from the usual one that we just showed here. So with this, the positions of these curves are helpful in determining the parabola. This is a parabola, however, a parabola is a special type of quadratic. And it has a directrix, a focus, and a vertex. And we'll talk about that. So stay tuned, don't go away. So we have our answers for parabola here, which is contained in y-axis and the x-axis. So this is our parabola, as you see on your screen here. This is our parabola. We have this point, a point P, which its length from that to this point on the x-axis is the same as the length of its image, the image of the point, to the same point on the x-axis. So it's equidistant, the same distance here. So the point that you see here is what we call the focus. And then the point that we have here is what we call the vertex. And this line that you see here is what we call the directrix. The directrix. And obviously, this is what we call the focal length, the distance between the vertex and the focus. And we've already talked about what parabola is. That is the curve. Let's talk about the definition of parabola. Parabola is a set of all points in the plane that are equidistant from a fixed line, the directrix, and a fixed point, the focus, that is not on the line. It is a quadratic function of the form y being equal to a into bracket the difference of x and h square plus k, or y equals a x squared plus bx plus c. Forms of the equation of a parabola. The rectangular coordinate system enables us to translate a parabola geometric definition to an algebraic equation. So let's consider the figure here. Now the figure that we see here, this figure tells us that the distance, which is d1 to the directrix, this is the directrix, so the distance d1 to the directrix, that's from this point P to the directrix, is equal to the distance d2 from the point to the focus. So therefore we can then say that the point xy is on the parabola if and only if d1 equals d2. The distance here is the same as the distance there. So if this condition is not fulfilled, then we say that it's not a parabola. So all these things have to be part. So that actually differentiates and makes it special, a special quadratic curve that is different from the normal quadratic because it contains a directrix, a focus, and a vertex. Now let's consider distance here. As we said, we already know the formula for distance between 2 points. So the distance here between this point and that point, first of all, let's consider this point first, the d1. Okay, so the d1, find the distance will be, we already know what the formula is. That's the difference between the x-axis, the square of the difference between the x-axis, order to the square of the difference between the y-axis, all square rooted. And so here, our x-axis, which is here our x-axis for m, the point m is minus p, and that of the point p is x. So that's what we have there. So the difference, minus minus makes it plus, and that's the reason why we have plus here in all squared. Plus, now we have the y-axis. Here you notice that we use x as our x2. So our y here will be y2. So y minus y, and that's what we have there. And this is equal to, now we find the distance between this, the point P and the focus, and that's what we've done here. And that, now this is a situation where we have our focus to be, our y to be 0, and our focus is on the x-axis, on the point P. So we are left with this because we know that the square roots will cancel each other. And we're left with this expression here, be equal to that expression. So that being said, we expand each expression. This is a perfect square. So expanding, we have x squared plus 2px plus p squared. And this equals to x squared minus 2px plus p squared plus y squared. So you notice that this x squared will cancel the x squared at the right hand side. So x squared will be eliminated or taken off. And we'll be left with 2px. And obviously we also notice that there is a minus 2px here. So it's not going to cancel each other because if 2px minus 2px comes to the left hand side, it becomes positive, and that makes it 4.4px. However, we have a p square here, and we also have a p square here. So this p square cancels the p square on the right hand side, and that leads to us being left with 2px equal to minus 2px plus y squared. And making y squared the subject, we have y squared to be equal to 4px. And that being said, we then can say or conclude on that by saying the standard form of the equation of a parabola with vertex at the origin which is 0, 0, point 0 and 0 is this equation here, or that equation there. Now the reason why we have y squared be equal to 4px will be explained later as you continue watching here. Or x squared be equal to 4py. All these will be explained as you watch. Don't move away, continue watching them. And please subscribe to KK Mathematics. The reason why we talked about this is because now let's talk about the other form of the parabola. Very important here. So, in considering the other form of parabola, as we stated earlier on, that y squared equals 4px is very important here because what? This is what we see that the curve is actually facing the x-axis. So since it's facing the x-axis, we have our focus to be here. Here, the p, which is the x-axis, is, so the point here is p, which is on the x-axis, and our y-axis happens to be 0. So this gives us that, and our directrix here will be x being equal to minus p. Now always remember, you see, the focus, the point, the x-axis here, that's the what. So just as we said earlier on, that the point from the focus to that of the vertex is the same or is equidistant to the vertex from the vertex to the directrix. So it's the main reason why we have minus p here. So if you have our focus here, then our directrix will be what? Will be a point that is negated, the negation of the point on the focus, or the point of the focus. So this applies the same thing to when we have x squared equal to 4py. This is what we are used to. We see that we have a curve and that's facing the y-axis. With this particular curve that we see here, with point P here, you notice that the focus here is 0 for the x-axis, and our y here is P, and our directrix here is y equal to minus P here. So that means that, as I already said, the focus from the focus then to the vertex is the same distance from the vertex to the directrix. Don't be confused of the distance, the short distance that you see here, from here to there and from there to there. What you need to know is that the distance from the focus to the vertex is the same distance from the vertex to the directrix. The y that you see here is actually indicating the point on the y-axis, and that is minus p here. The other form of the parabola here. Now, we also consider the aspect of y squared equal to minus 4px. In this case, we notice that our curve is rather facing the negative aspect of the x-axis. So, since it's facing there, we have our focus to be minus p. Minus p, that is the x coordinates, which is minus p. So you notice that the points here on this four parts of the x-axis are all negative. That's why we have minus p here. And we know that what's our 0? We know that y coordinate is 0. And our directrix here. So if our directrix here is positive, is negative here. Sorry, if our focus is negative, then our directrix will be positive. And if our focus is x, the x coordinate here is p minus p, then the directrix will be x equal to p. And then considering x squared be equal to minus 4py, this tells us that in this particular one, we notice that the curve is actually facing the negative aspect of the y-axis. So in the negative aspect of the y-axis, we notice that with the points P, with the focus, containing coordinates 0 and minus P, which actually is indicating that our y coordinate is minus P. That's because all the values here are all negative values. So we have our y coordinate to be minus P. And if our y coordinate is minus p, then our directrix here will be positive. So always have in mind that if your focus, if your focus is negative, then your directrix will be positive. But it depends sometimes, especially if you're dealing with the general form of the parabola or the general equation of the parabola or standard form of the equation of the parabola, then you can consider this. By another form, it's not so. Before we go on to solve an example here, it's very important for you, if you've not subscribed now, please do so, and like and share. Do so right now, and let's continue. Let's consider an illustrative example here. How to find the focus and directrix if given a parabola equation. Example 1. Find the focus and directrix of the parabola with equation I y squared equal to 12x, I y squared equals minus 4x. Solution here. Compare the given equation with the standard equation. We have y squared to be equal to 4px. This is the standard form of the parabola, or standard equation of the parabola. Either this or that, where we know the coordinate to be this. Now, in comparing this to that, here, this tells us that our coordinates here, this means that in looking at this particular formula here, this even tells us that the curve will be the curve. So we notice that that means that the curve will actually be on the x-axis. Okay, so since the curve will be on the right side of the x-axis, we have that the point to be x-axis to be and y coordinate to be 0, and that's the focus. And our x is minus b, or x equals minus a if you're using this formula, which is the same thing here, to be, and that is to be our directory. So in considering I here, we have our 4p to be equal to 12, right? So that p, so by this we can find our p to be equal to 3. Don't be confused here. We have 4p here. Notice, with the general equation here, we compare to each other, and by comparing, we were left with 4p be equal to what? 12. So by comparing this to this, we were left with 4p be equal to 12. And that gave us the opportunities for us to find our p, which is equal to 3. Therefore, the focus is 3 and 0 already. Okay, so we know our p, which is 3, so 3 and 0, and the directory says x be equal to minus 3. Now we do the same for II. So by comparing this to the general form, which is y squared be equal to 4px, we'll be left with 4p be equal to minus 4, and by that we can find our p, which is minus 1. Therefore our focus is minus 1, 0, minus 1, 0, and the direction is x be equal to 1. Let's consider finding the equation of a parabola when the focus and directories are given. Okay, so illustrative example here. Find the equation of the parabola in the standard form whose focus is 7 over 2, 0, and direction is 2x plus 7 equals 0. Solution here. Now let Px, the point P containing of the coordinates x and y, be any point on the parabola whose focus is this, and our directories is 2x plus 7 equals 0, which is exactly equal to x being equal to minus 7 over 2. So we know our focus, that the x-axis of the focus is 7 over 2, and the directions is minus 7 over 2. So we can then say that that is our p, because we know that according to the standard, the general standard equation of the parabola, we have our p. Okay, p is normally on the focus. We have our p to be the point on either the x coordinate or the y coordinates. But in this particular question, that our p here is the x coordinate here, and that is 7 divided by 2. And so by this, with a general equation or general standard or the standard form of the equation, which is y squared be equal to 4px, we just have to substitute wherever we have our p by 7 divided by 2. So this is where the p is, and we've replaced the p with 7 divided by 2. I mean, 2 goes into 4 2 times. And so that 2 multiplies 7, giving us 14x. And by that, this is our answer. Therefore, we conclude the equation of the parabola is y squared equal to 14x. Watch out for part 2 of this, and please subscribe. Click on the notification bell, like it, and share it. Thank you very much. This is KK Mathematics, the solution to your mathematics. Bye for now.